Alright, so we're going to review for our Unit 3 test. It's going to be over quadratics, composition of functions, composite functions, and it's also going to be over inverses. So on quadratics, the first thing I'm going to review with you is how to graph the parent function. The parent function has a point at the origin, 0, 0. I go right 1, up 1, and we've got a point at 1, 1. And then from the vertex, we're going to go left 1, up 1, and have a point at negative 1, positive 1. And it makes this U shape that we call a parabola. Number 2 is also a parabola, but it's got a vertical compression of 1/2. Since we're just going to compress it and we're not moving it left or right or up and down, it still has a vertex at 0, 0. We're still going to go right 1, but I'm not going to go up 1. I'm going to go up 1/2. And I'm still going to go left 1, but only up 1/2. So this 1/2 is telling me how far I'm going up. It's your vertical stretch or compression. In this case, a compression. On number 4, we have a little bit more going on. On number 4, we're actually going to shift our parabola up 4 units. 1, 2, 3, 4. And I'm going to have a stretch of 3. So from this vertex point right here at 0, 4, I'm going to go right 1, and I'm going to go up a stretch of 3. So right 1, up 3, and then from the vertex, I'm going to go left 1, up 3. So you'll notice it gets a little bit skinnier with the vertical stretch, and it's shifted up 4. Number 4, the parabola is going to move down 3, 1, 2, 3. And there's also going to be a stretch of 2. But this time, instead of going up, because there's a negative, it's going to go down. So I'm going to go right 1 from the vertex and down 2. And then I'm going to go left 1 from the vertex and down 2. So this one's going to be a parabola that is reflected over the x, shifted down 3, and also gets a little skinnier. And we did this on our last test too, so this is kind of a reteach review. On number 5 and 6, they give me a picture of a quadratic, and they want me to write the equation in vertex form and standard form. So when you're writing in vertex form, obviously the first thing I want to have is the vertex. So 1, 2, 3, it looks like I have a vertex at negative 3, comma, 0. It opens up, which means I'm going to have a positive x squared. Let's see if there's a stretch. Right 1, up 1. No, there's no stretch. So when you write this in vertex form, we're going to have y equals parentheses. There's no number out here because there's no stretch. Inside the parentheses, we're going to put the x coordinate, and we're going to put the opposite of what's there. Since this says negative 3, we're going to put a plus 3. I'm going to square. I didn't shift up or down at all, so there won't be a constant out here. To take this equation and put it in standard form, we have to FOIL the equation above. X plus 3 times x plus 3. And you can FOIL it by hand, or you can use the shortcut method we talked about in class. The shortcut method says you take the first term and you square it. X times x is x squared. You take the last term and you square it. 3 times 3 is 9. And that'll give you your first and your last number. To get your middle term, you multiply these two together and then you double it. X times 3 is 3x. 3x doubled is 6x. If you don't want to remember that, that's okay. You can go ahead and FOIL. X times x is x squared. And x times 3 is 3x. And then we go the other way. 3 times x is another 3x. And 3 times 3 is 9. 3x and 3x gives me the 6. So you can either FOIL if you want, or if you don't want to FOIL, you can do the shortcut. Either way will get you the right equation. On number 6, again, let's go find the vertex first. It looks like we went right 2 and up 1. So when I come up here to write my equation, it's going to be y equals. It opens up, so it's going to be a positive. From the vertex, right 1, up 1. So again, there's no stretch. So outside the parentheses, I need a positive 1. We don't have to write that. Inside, I write my x, and I write the opposite of my x coordinate. I put my square out here. And for the vertical change, you write exactly what it is, so we write plus 1. We're going to repeat exactly what we did over here to put it in standard form. You may FOIL or use the shortcut, whichever one works for you. So on the shortcut method, I'm going to have the first number squared, the second number squared. I'm going to multiply these two and double them. So x times negative 2 is negative 2x, and negative 2x doubled is negative 4x. But don't forget to bring down that plus 1. So I have to go combine like terms one more time, and 4 plus 1 is 5. So this is the answer that I need. Okay, on 7 through 9, they're asking me to use the formula negative b over 2a. And this formula will be given to you on your test. So you don't have to memorize this, you just have to know what it's for. This formula is going to give you the x-coordinate of the vertex, which is also the same as your axis of symmetry. So when I'm plugging in, before you plug in, you have to know what a and b are. So a is the number in front of x squared, which is 1, and b is the number in front of x, which is 5. So now I just go plug into the formula. So I'm going to have negative 5 over 2 times 1. Wait a minute, on this problem I forgot. I changed this to an 8 in class and I forgot to do it here, so let's go ahead and do that real quick. Otherwise we get a nasty fraction, I didn't want to deal with that. Okay, so let's try this again. So the a is the 1, the b is the 8. Remember I changed it in class, I told y'all in class to change that one. So we have negative 8 divided by 2 times 1. So negative 8 over 2. And negative 8 over 2 is negative 4. So that's going to be your x-coordinate. It's also your axis of symmetry. They're always going to be the same right here. To finish up the vertex, I have to go find my y-coordinate. To get the y-coordinate, you take the answer that we just got here, and you're going to go plug it in to these two x spots. So I'm going to have y equals parentheses negative 4 squared, because it says x squared, plus 8 times negative 4. Negative 4 squared is 16. 8 times negative 4 is negative 32. 16 take away negative 32 is negative 16. So there's my vertex. To find your intercepts, to find our x-intercept, we're going to let y equal 0 and solve. So x squared plus 8x equals 0. To solve this quadratic that has two terms, we factor out a GCF, and we get x plus 8. I'm going to go solve each one of those, x equals 0, and x plus 8 equals 0. This one's already solved for. This one would be x equals negative 8. So my intercepts are 0, 0, which would also be the y-intercept, and negative 8, 0. Okay, the only difference between number 7 and number 8 is there's a negative here. So this would be a good time to pause the video, try it on your own, and come back and check your answer. Alright, so hopefully you paused it and you've tried this already on your own. So a equals 1 and b equals negative 6. I'm going to plug into my formula again right here. Negative b divided by 2a. So the opposite of negative 6 is positive 6. Divided by 2 times 1 is going to give me 6 over 2. And 6 over 2 is 3. Again, these two answers are going to be the same. And now you're going to take the answer we just got of 3 and plug it into the original equation. So y is going to equal 3 squared minus 6 times 3. 3 squared is 9. 6 times 3 is 18. 9 minus 18 is negative 9. So there's my vertex. I'm going to go find my intercepts exactly like I did on the first problem. So I'm going to find the x-intercept first. I'm going to let the equation equal 0. Again, it's a two-term quadratic, so I'm hoping that there's a GCF, and there is, of x. I'm going to set each factor equal to 0. So x equals 0 is already solved for. And then x minus 6 equals 0 is going to give me x equals positive 6. So my intercepts are 0, 0. That's the x-intercept and a y-intercept. And 6, 0. All right, number 9 is very similar to the other two, except that it has a C term. You should still be able to get the vertex and the axis of symmetry exactly the same way. So again, pause the video, try it on your own. We're still going to factor to get the intercepts, but we're going to factor a little bit differently because there are 3 and because there's a negative. All right, so we'll start with the vertex again. So we're going to do A this time is negative 1, so you have to be careful. B is negative 4. C is 12, but I don't need it for the formula, so I'm not going to worry about it. So we're going to take the opposite of B, which is 4, divided by 2 times A. So 4 divided by negative 2 is going to give me negative 2. Again, these two are the same. To get the y, I'm going to do exactly what we did earlier. I'm going to go plug back into this original equation. So everywhere there's an x, I'm putting my negative 2 in. All right. So we've got negative 2 squared, which is 4. But then I had a negative out here. So I've got negative 4. Negative 4 times negative 2 is a positive 8. And then I have to bring down my plus 12. Remember we talked about this. Order matters. Negative 4 plus 8 is positive 4. And then 4 plus 12 is going to give me 16. All right, so the intercepts, we're still going to set it equal to 0, and we're still going to factor. But because there's a negative x squared, you may not remember how to do this. So I'm just going to review it real quick. You don't want to factor with a negative x squared. If you're using the quadratic formula, it wouldn't matter. So we're going to factor out the negative first. So everybody changes their signs so that I can factor out the negative. And then we're going to make our 2 parentheses. Now remember, when we make our 2 parentheses, if it's a 1x squared, this is actually pretty easy. If I have a 1x squared, they both get an x. And then you look at the last number. I look at the negative 12. And I'm trying to figure out what factors of negative 12 add up to 4. So my factors of negative 12 are negative 1 and 12, negative 12 and 1, negative 2 and 6, negative 6 and 2, negative 3 and 4, and negative 4 and 3. And one of these factors adds up to positive 4. So I'm going to go pick the ones that add up to positive 4 and put them inside here. And then all I have left to do is to make these factors equal 0. So x minus 2 equals 0. So x equals 2. X plus 6 equals 0. So x equals negative 6. So I have 2 intercepts. I have the intercept of 2, 0 and the intercept of negative 6, 0. Now this time, I didn't get a y-intercept like I did on the other two. I'm going to have to go find it. So this was all my work for the x-intercept. To get the y-intercept, I have to go back to my original equation, and everywhere there's an x, I have to plug in 0. Well, I know most y'all can do this in your head, but I'm just going to show the work anyway. Everywhere there's an x, I'm going to put in a 0. This is to get the y-intercept. Obviously, 0 squared is 0. 4 times 0 is still 0. Plus 12, so 0, 0, and 12 is going to give me a y-intercept of 12. So 0, 12. All right, so everything on 1 through 9 is what you need to know about quadratics. Now let's go talk about composite functions. So 10 through 13 is just a matter of plug it in, plug it in. It's just if you understand the notation. So this one says you're going to use the functions f and g. And we're going to do the one that's inside first. And the one that's inside is the g. So I come over here to that equation, and I do g of 7 equals 4 times 7 minus 2. Well, 4 times 7 is 28, and 28 take away 2 is 26. Now I'm going to take that answer 26, and I'm going to plug it into my outside equation. So we're going to have f of 26 equals the square root of, because that's what it says, x, 26 plus 10. Well, 26 plus 10 would be the square root of 36, which is 6. So your last answer is your final answer. Number 11 is going to work the same way, but notice they're using 2 different functions. They're doing k of h of 2. So this tells me I have to do the h first. H is right here. So I'm going to do h of 2 equals 2. Parentheses. Now I'm going to plug in my 2 squared minus 1. 2 squared is 4. And 4 times 2 is 8. Take away 1 is 7. So let's do that again. 2 squared is 4. 2 times 4 is 8. Take away 1 is 7. Now I'm going to take that 7 and plug it into the k equation. So I'm going to do k of 7. So 5 parentheses 7 plus 3. 5 times 7 is 35, plus 3 is 38. Again, your last answer is your final answer. So if they ask you to plug in a number, you plug it into the one that's closest to it first, you get that answer, and then plug it into the outside. On 12 and 13, we're going to be plugging x into the equations instead of numbers. So we've got k and g this time. So g of x equals 4x minus 2. Now I'm going to take this whole thing, 4x minus 2, and I'm going to plug it in over here for k. So k of 4x minus 2 equals, it says 5 parentheses because it has an x. I'm going to put my 4x minus 2 in there and then bring down my plus 3. Okay, so if I distribute, I get 20x minus 10 plus 3. So when I go combine like terms, we get 20x, negative 10 plus 3 is negative 7. Your last answer is your final answer. So that's the one that goes in that spot right there. All right, number 13 is going to be the same process as number 12. Maybe you want to pause the video right now and try one on your own. Okay, so hopefully you've already tried 13. We're going to do k of m of x. So m of x equals x minus 3 over 5. Now a lot of times you'll get to these problems and you freak out because there's a fraction. You're going to have these all year long, so we've got to get used to them. So I'm going to take this m and plug it into k. K is right here. So we're going to have 5 times x minus 3 over 5. And then I have to remember to go add my plus 3. So when I multiply this 5 by this fraction that has a denominator of 5, these 5's cancel. And we're left with x minus 3 plus 3. My x's cancel. And my last answer is my final answer, which is x. So on 14 and 15, they want us to decide whether the functions are equal to x. And this is when we have to do the f of g of x and the g of f of x, and we have to decide if they're equal to each other. So f of g of x. So I'm going to take this equation right here, the square root of x minus 3, and I'm going to plug it in right here where it says x squared. So in place of the x, I'm going to put the square root of x minus 3 squared, and then I'm going to put plus 3. Now I'm going to go FOIL this. I'm going to use my trick that we talked about to FOIL. Okay, so to FOIL this, I take the first term and I square it. Well, the square root of x squared is just going to give me x. Negative 3 squared is going to give me 9. I'm going to multiply these together. Negative 3 times the square root of x is negative 3 square roots of x, and then I'm going to double it. And I'm going to bring down my plus 3. Okay, so if I combine like terms here, will this one equal x? No. Okay, so I did one way, I did f of g of x. Now I have to go do the other way. I have to go do g of f of x. So I'm going to go to this equation right here, and I'm going to take x squared plus 3 and plug it in underneath. So underneath, I'm going to have x squared plus 3, and then I'm going to bring down my minus 3. Okay, the square root of x squared. If it's square root of x squared, that would come out, but that plus 3 is going to stay in here, and then I've got a minus 3 out here. These don't cancel. You can't subtract the square root of 3 and this, you can't subtract the 3 under the house with the 3 outside the house. So this is another no. So this is a double no. So this would be letter B, no, no. Okay, let's go look at 15. It's going to work the same way. We're just going to plug in and see if it equals x or not. So we're going to do f of g of x. So we're going to start with this g of x equation, and I'm going to plug it in right here. So 2 parentheses 1 over 2x. So if I go and I distribute this, I get 2 over 2x. And if I go and I cancel, I got 1 over x. That's close to what I want, but I don't want 1 over x. So unfortunately, this is also a no. Okay? Now we're going to go the other way. G of f of x. And I'm going to take this 2x right here, and I'm going to plug it in down here at the bottom. So I'm going to have 1 over 2 parentheses. And then inside that parentheses, I'm going to put 2x. So I took this and I plugged it in right there in place of that x. Then I simplify that and I get 1 over 4x. Again, I didn't get just x, I got 1 over 4x. This happens to be another another B. Alright, so that's it for composites. The rest of the review sheet is going to have to do with inverses, and y'all are actually really good at inverses. On number 16 and 17, they want to know, look at these ordered pairs, decide if it's 1 to 1, If it's 1 to 1, either find the inverse or graph the inverse depending on which problem we're doing. So when you're looking at ordered pairs, we're looking at the x's and the y's, and nobody gets to repeat. So my x's are 2, 3, 4, 5. Nobody repeated. That's good. My y's are 27, 28, 29, and 30. All right, well, nobody repeated. So if nobody repeats, yes, it's 1 to 1. And if it's 1 to 1, I can find the inverse, which just means I flip the points. And that's it. So pause the video for a quick second. Try number 11. And then we'll come back and check and see how you did. Okay, so hopefully you're back and you're looking at these and said 11, 12, 16, 18, 14, 7, 14, 14. These repeat, so this is a no. Because it's a no, we're not going to write the inverse. 18, 19, and 20, we're going to do that new thing we learned, or the review we learned about the horizontal line test. If I were to take my pen and go like this up the graph, I want to know how many times I touch each time I move up. I only touch the graph each time I move 1 time. So this is a 1-to-1 function if it only touches once. If it's 1 to 1, we're going to go graph the inverse. Now on the test, Ms. Puckett is going to have the line y equals x already on there for you, so that you remember that that's the mirror image line. And we're going to go graph the inverse. We're going to pick some points. So I have this point right here, -4, 0. Well, if I flip that, I get 0, -4, 1, 2, 3, 4. I also have this point up here, 0, 1. I'm sorry, it's not 0, 1, it's 0, 2. So I'm going to go graph the point 2, 0. So when I do mine, it's going to be the mirror image across this black line here. And it's going to look something like that. There's my inverse. You could see that if I were to fold this on the dashed line, that this piece would match up perfectly with this. Number 19, we're going to go do the vertical line test again. When I do my vertical line test, no matter where I draw a horizontal line, it passes. So this is another yes. I'm going to go draw that y equals x line in here for us. And again, just pick 2 points and flip just those 2 points. So it looks like I have a point at 0, 1, so I'm going to go put a point at 1, 0. And it looks like there's another point, it looks like around -0.5, 0. So I'm going to go put it around the same spot. Okay, and then I'm going to go draw my line. And again, you could see that these 2 parts would be mirror images. If I just kind of look like this, these would flip over. And if I looked at this side, it would flip over. On number 20, we're actually going to see the first time that it doesn't pass the horizontal line test because how many points come up? 2. And you're only allowed to touch it 1 time. So this is going to be a no. Because it's a no, I don't have to worry about the picture. On 21 through 23, we're simply going to find the inverses. Y'all are really good at this part. So we're going to go make this say y equals. And then we're going to flip our x and y. And then all we have to do is solve for y. So to get y by itself, I'm going to subtract 10. I have a 4y, but I want a 1y, so I divide everything by 4. So we have y equals, so you look at all 3 terms, and all 3 terms have to be divisible by 1 number in order to divide. And I know some of y'all think, well, the 10 and the 4 are both even, but there's nothing out here in front of the 2, so that's an illegal move. You cannot do it. So you leave it like it is, x minus 10 over 4. So let's go use our fancy notation. Inverse is equal to x minus 10 over 4, or, we talked about this a lot in class, remember, sometimes on the test they're going to leave it like this, and sometimes they're going to take the denominator and write it as a fraction. So if I have a 4 on the bottom and nothing out here out front, it's like having 1/4, and then I put parentheses around what my numerator is. So either one of these equations would be exactly the same and are both acceptable answers. Okay, let's go look at number 22. We're going to follow the exact same steps. F of x becomes y equals. I'm going to go switch where my x's and my y's are. And I'm going to go solve for y. In order to solve this problem, the first thing I would like to do is to make the fraction go away. So to make the 4 go away, I'm going to multiply both sides of the equation by 4. When I do that, I get 4x equals, these 4's will cancel, and I'm left with 3y plus 5. To get y by itself, I have to subtract the 5. And that says 3 times y, so again, we're going to divide. And when I divide, use my fancy notation again, I have inverse equals 4x minus 5 over 3, because I can't divide one number into all of them. Or, on the bottom I have a 3, so I could write the fraction 1/3 and then put parentheses where the numerator is. So both of these answers are the same. Again, you just need to know that they're equivalent. Number 23 is a cube problem, but we're going to start it off exactly the same way. We're going to switch the x and the y. In order to get this y by itself, I have to untrap it. Right now it's trapped by this cube. So to untrap a cube, we cube root both sides. So I have the cube root of x equals, the cube and the cube root cancel, and I'm left with y plus 1. To get y by itself, I have to subtract the 1. So I have the cube root of x minus 1. Notice this 1 is not under the radical. So when we go write our fancy answer, we've got the cube root of x minus 1. Again, that minus 1 is not under here. On 24 through 26, they say decide whether the functions are inverses of each other. 2 ways to do this. You can do the composite functions and see if they both equal x, or you can do it the easy way and just solve one of these for the inverses to see if it matches the other. Okay, so I'm going to do it the easy way because that's the way y'all seem to like in class. So I'm going to go solve this equation right here, just like we did up here. And if I get this equation, that means they're inverses. If I don't get this equation, then they're not. So x equals 3y plus 2. I'm going to subtract the 2, and then I'm going to divide by 3. So we get x minus 2 over 3. Now a lot of y'all look at that and go, oh, they don't match. But remember what we just did up here on both of these problems. I said, whatever you're dividing by is also the fraction. So dividing by 3 is the same as multiplying by 1/3. And then you put the numerator in parentheses. Do they match? Yes, they do. So this is a yes. Okay, let's go look at 25. Same approach. So I'm going to change that to a y. And now I'm going to switch them. X equals 5 minus 7y. I'm going to move the 5 over, but notice the 5 is not negative. It's the 7 that's negative. So when I move the 5 over, it's x minus 5 equals negative 7y. I'm going to go divide by negative 7. So we have x minus 5 over negative 7. Or we have negative 1/7 x minus 5. Well, this has an x minus 5. It has a 7. It has an x over 7. And it didn't even have a negative. So this time, we've actually got a no. These do not match. All right, last problem. On number 26, same approach. Change this to a y. X equals 5y plus 1. I'm going to move the 1 over. And then I'm going to divide by 5. And I get x minus 1 over 5. Or 1/5 x minus 1. And it looks like I have a 1/5 x minus 1. Because 1/5 times x is x over 5. But 1/5 times negative 1, I would need this to be a negative 1/5. So they almost look right, but they're not. It's another no. I hope this video helped. I'm going to encourage you to watch it again on Sunday since you're to actually have a test on a Monday. Good luck. Study hard, Wildcats.